Hello. Hi. So we have Ashwini Oruganti from India today, and she's gonna speak to us about, well, her talk is titled Kneel and Disconnect. Thank you. Please welcome Ashwini.
Hi, everyone. Thanks for coming to this talk. Kneel and Disconnect is actually a song by Porcupine Tree. I did not make up the cool name myself. This talk is about a happy eyeballs algorithm that I implemented and twisted in an endpoint called the Hostname Endpoint. Today in this talk, I'm going to talk about all the classic async programming mistakes that I made through the way, and how to do things right. That way you can do them right from the get-go. And hopefully you'll also get a glimpse of the amazingly awesome community that Twisted has. And I'm Ashwini. I'm studying computer science in Manipal, India. And lately I've been working on a PHP VM called Hippie. That's an implementation in PyPy. So, well, happy eyeballs. I implemented this because it sounded cool. No, I'm lying. I implemented this because everyone kept telling me that it's a crazily complicated endpoint. And if you're not me, you might actually want to know why the algorithm exists and how it is useful. But the way I operate, I really didn't get to know all of that until after I implemented it. So endpoints in Twisted, they're APIs that separate the implementation of servers and clients from what they're supposed to do. So a client endpoint basically has a connect method that takes a factory and returns a deferred firing with a connected protocol. Hostname endpoint in particular takes a host name, resolves it into multiple host addresses, and returns the connection to the host that is established first. So the name resolution part here is done by socket's GAI method. And the way this works is that when you pass a host name to this method, it resolves it into multiple host addresses, returns a list of those connectable hosts. And note that these addresses can be IPv4 or IPv6. What this means for us is that when you want to connect to a server, you need to identify it with an address. So IPv4 is the fourth revision of Internet Protocol and uses a 32-bit addressing scheme. This gives us just over 4 billion addresses. But turns out the web is expanding so fast that this is not enough. We started running short of addresses. Now that's where IPv6 comes in and saves the day, basically. It uses 128-bit addressing scheme and gives us many, many more addresses. And the long-term goal is to transition to it completely, eventually. But by default, applications do prefer IPv6 because, after all, it's the internet of the future. But turns out that although most of the applications have this IPv6 addresses, they do not work properly in the servers. So if a server's IPv4 path and protocol are working, but IPv6 connectivity is impaired, today's IPv6 capable applications like web browsers, email clients, all of those would, let's say, they would incur a few seconds of delay. Not seconds, I don't know how long it will take, but yeah, it will incur some delay before falling back to IPv4. And that harms the application performance and users' experience with IPv6 and slows down its acceptance. And that's a problem. So Happy Eyeballs algorithm solves this problem for us. It says that once we have the list of resolved host addresses, we should connect to it in the order in which they are returned and return the connection that is established first. This means that we are trying to connect to multiple hosts host addresses that was returned to us. But the thing is that, okay, initially when I heard this algorithm, I thought that, okay, maybe what we want to do here is connect to the first address and record how long that took, then the next address in the list, record how long that takes, then compare the 2 times, and then probably the one that takes lesser time, connect to that one. But I was very wrong. What happens here, the high-level objective of this algorithm is to return a connection as quickly as possible. And the example that I just explained used 3 connects, and that would take a lot of time. So what we do is we initiate several connections in parallel, and then the one that connects first is returned while the others are dropped. But another objective of this algorithm, and let's say now endpoint, because we are starting to talk about the endpoint, is to basically save network resources. And if the first host addresses connection is established quickly enough, then it would be a waste of resources to connect to other addresses as well. So we introduce a 300 millisecond delay. That means that we don't actually initiate all the connections together. Just subsequent connections are initiated after a little bit of delay. So now moving on. This is a twisted endpoint, and we want to do parallel things in it. How do we do that? Twisted is an asynchronous, event-driven networking framework, and I just want parallel things. So, well, the good news is that Twisted is good at doing parallel things, especially related to network operations. The reactor, the Twisted reactor, is good at doing multiple things at once. By doing multiple things, I mean that it waits for multiple things at once. And that's its job, essentially. So what happens here is that connect TCP returns immediately. It doesn't wait for the connection to actually be established. It just returns, it initiates the process of starting a TCP connection, and then returns a deferred. And the reactor calls this method F when the connection is finally done and established, so that way we need to specify a callback that would be called so that we know that the connection is done. Now, the second part of the algorithm was about scheduling delayed calls. The reactor has a method called call later that does this for us. And in this, we are basically scheduling a call to the function f after 5 seconds. So that's what that does. And now that I knew that what I needed to do and that Twisted was capable of letting me do this, I looked into how to write unit tests for this, because the spec is kind of complicated, and the only way to know if we've done it right is to do it the test-driven development way. So the first thing that I needed to know was, should I use the real reactor in the tests or not? So what happens here is that when I do this, the reactor actually tries to deal with the operating system events in real time, talks to the external world, but during testing, during unit testing especially, we should limit our contact with the external world as much as possible. And Reactor doesn't do that for us. It is the means to talk to the outside world, and we need to avoid that. So we can't do this. That's wrong. Well, not wrong, but that's not advisable, I'd say. So there's a test double called clock in Twisted that almost does the same things that we would want to test for in a reactor. It has a call later method that schedules delayed calls, and it has a method called advance. So what's happening here is we are telling clock, initially we are telling it that, okay, this is a function that I want to call after 5 seconds. And then second, we are saying that, okay, hey, I want to know what would happen if time advanced by 5 seconds, what all events would take place, and basically triggers the, so it's like time is frozen, and we are advancing the clock, as, as in how we like. So now, moving on to the implementation, I didn't have a name for this. It wasn't always called a hostname endpoint. So we had a discussion about it. The first suggestion was hostname endpoint because it takes a hostname and connects to it over whatever protocol is appropriate. The next suggestion was TCP endpoint, mostly because we hadn't used the name yet, but also because the connection was established via TCP. But the thing is, host names are not parts of TCP. They are not even part of IP. They are parts of DNS. And 99% of this endpoint's functionality was DNS. So DNS endpoint. But then again, DNS can be used to resolve names for other things as well. And this endpoint won't let us do that. It's just to establish connections to servers and clients using TCP. So this name wasn't right either. So the important thing to remember here is that TCP and DNS, these are all implementation details. They are important implementation details, but nevertheless, they are that. So what we need to remember about this endpoint is that it takes a host name and connects to it, gives us the connection. So hostname endpoint it was. Now moving on to the implementation, I had no idea how to go about it. It was, even if I did understand the spec after a lot of, I don't know, speculation, it did make sense, but I had no idea where to start. So John Paul, who was my mentor during my Google Summer of Code project, which I was doing around the same time, suggested a few simple steps to get started. The first one is just listing its features on a piece of paper or a TXT file, something simple. Next was sorting them. Now, the idea behind sorting it from the simplest to the most complex is that the complicated things are only complicated when you try to do them all at once. So if you first finish implementing or dealing with the simple things or simple parts of the endpoint, then the complicated parts don't seem so complicated after all. So that was the second step. Now the third one was write a unit test for the first thing in that list, which made sense because I already talked about test-driven development. So coming to the writing test part, okay, before that, now I'm going to list out all the different mistakes that I made throughout this endpoints development. The first one was that when I was trying to implement it, I was trying to catch a failure that was supposed to return an exception in an except block. And I had a unit test for this, and it was failing. And I was kind of confused about what was happening. And turns out it's the way that deferreds work. What they do is, like what the first line would do is, it would give me a connection, and the deferred D would fire with a callback on it or an errback. The important thing here is that D is returned. And the way Python functions work is that you can either return or you can raise, but you cannot do both. And since it was returning something, this thing was wrong. The right thing to do here would have been this. We could have stuck an errback over the deferred, and that would do the error handling for us. So this was the first mistake I made, and I learned something out of it. Second one, when you're using test-driven development, this is the pattern that you're supposed to get. First, you write a test that fails, then you implement the feature, and the tests pass. You write another test that fails, you implement another feature, and things pass. But the pattern that I was getting was this. And it was weird, but all my tests had one thing in common that were resulting in a timeout during the run. It was the last line. The mistake I was doing here is that I was returning a deferred from the tests. I was told that doing this would spin the global twisted reactor, and we don't want to do that for reasons that I had mentioned before, that reactor is a means to connect to the outside world. When I spin a twisted reactor, global reactor, what it does is it tries to, again, connect to the outside world. And the tests wait for some message to come back from there and wait forever, basically. But trial, the twisted test suite, defines forever to be about 120 seconds, I think. So it was timing out. The tests were timing out. So the lesson to be learned here is that we don't want to return deferreds from tests. We don't want to do that because when we are running a set of unit tests, we want to limit how much we talk to external things. You might need to be doing this if your tests are talking to some external database or things like that. But even in case you need to do that, you need to remember a simple basic rule that probably your unit test shouldn't be talking to things outside of your application. So that was something else that I needed to remember. Never ever return deferreds from unit tests unless you really have to. And if you have to, just rethink the design of your API. Okay, moving on to so this is the right thing to do. I just removed that one line, and all my unit tests were passing. So everyone was happy. Now, I mentioned something called clock.advance in the earlier slides. It was to move forward the time, because time was frozen in a test double of the reactor. The thing is that so far I was not dealing with the scheduled call parts of the endpoint, because remember, simple things first, complicated things later, right? So the simple things were working, and everything was good. Now, I just introduced a single line of delayed calls, and my tests were timing out again. They were failing, or sometimes timing out, but not in a way that would tell me what was going wrong. So I blamed call later for this, because when I didn't introduce that in my code, everything was working. I added that, and everything stopped working. And initially, 300 milliseconds was the time that I was using. I changed that to 0 seconds so that I would know what was going wrong. And 0 seconds is immediately, that's like right now, right? I wouldn't need to advance time for this. But turns out, I was wrong. I didn't get how all of this was working. So Glyph, who was the person who tried to write a video game and then ended up writing Twisted instead, he was helping me, he was answering my questions and helping me fix things in this endpoint. And he said that he quoted Morpheus from the Matrix, and he said that I was thinking too hard about it. He said that it's just a number. And the way clocks call later method works is that it collects all the calls that are to be made, then sorts them by number, where this number is the time of the scheduled call, and then calls them one by one. And that sort of made sense, and time was frozen, but still 0 seconds had to be, like, we had to tell the clock that 0 seconds have passed and it is supposed to move forward now. That's how test doubles work, and well, that's how things work there. I did sort of fall into more trouble, and the main reason behind all of this was that I was trying to put things together too hard. I was trying to understand the bigger picture and how things fit together, even before I implemented the smaller parts of the API. So again, this was Glyph's idea that I really need to stop thinking so hard about this. And he was right. Turns out you can do a lot without knowing why. Most of these are just things calling on other things, and there is no reason behind it sometimes even. It's just some list of things that you need to do, and the reactor needs an order, and the person who was implementing it chose a particular order, and that's about it. So this helped, and now it was running. We had a nice API. It seemed to follow the spec properly, but then was it perfect? The only way to know this was to get it for code review. The way Twisted's code review process works is that you work on a ticket, you submit it for review, people review it, and then they assign it back to you. You improve it with the comments, and you submit it back in the review. And someday, sometime, when it looks good, you get to merge it. So this is how the connect method for this endpoint looked. It was working, but it's like more than half of the methods are nested. And John Paul suggested that connect could possibly be implemented as an independent object instead of having so many nested functions inside it. He even suggested that implementing this through a finite state machine would be a great idea if we have a state machine framework for Twisted protocols. So by the way, if you're staying for the sprints, you should join us at Twisted. We can work on this together if that's something. So finite state machines are what's coming up next. Hopefully that will improve the way the code looked, the previous slide. And at last, I want to say that there will be a day when I will come up on the stage and talk about how I implemented some software that saved the world and, I don't know, defeated the aliens, gave us glorious victory, but today is not that day. Whenever I struggled, and I struggled a lot, there was help was always there. Sometime in the form of a code review, sometime as a pair programming session, sometimes as a simple reminder that I needed more sleep. So what I'm trying to say is that I wouldn't have been able to do this alone without the patient-wise and amazing mentorship by John Paul, Glyph, and in fact, all of the Twisted community. So what I'm saying is that I'm really happy to have all the friends here out there and the community. So thank you. And this is a link to the ticket in case you're interested in taking a look at the development yourself. And that's me on Twitter. You can tweet at me. You can tell me how horrible this talk went, or if you like something about it, you didn't like something. That would be great. So thank you.
Minutes for a question. If
Okay.
anybody has a question.
So any questions, anyone?
Okay, I guess no one has any questions?
Yes.
Okay, could you repeat the question, actually?
Okay, so I was asked why the algorithm is called Happy Eyeballs, which is a good question because it's a funny name. Out there, every web application wants the users to be there with it. And so the web uses the word happy eyeballs to refer to its audience, the people who are viewing this. So happy eyeballs algorithm basically means that the users of the web applications, and they're happy because this thing is working fine, right? So anyone else?
Then thank you, Ashwini, for your talk.
Thank you.